why you need Mechatronics, what it means. I explained the basic things, and we see that mechatronics are everywhere, and we are going to see little more detailed this one. Few products, mechatronic product, what it contains, what algorithm, how it is using, how it is working, basic to make an understanding. Okay. So as I told you that please make note, take notes, and also not only the pictures what I show on slide or bulleted points. Additionally, what I'm explaining also you have to take a point, like notes, so that you can write in exam. Because anyhow you will be evaluated based on exam. For that you have to take notes. What I'm talking, important points apart from the bulleted points, figures shown in the PPT. PPT has a minimal information. Remaining I am explaining. Those things you have to note down. Already you know that you have done 2 courses with me. At least 1 course with me, and the other 3 more courses with other 2 professors. So you know what is expected. So today we are talking about an example for a mechatronic system is an industrial robot which you would have seen in your factory. Here, this figure, you can see that this figure shows a this figure shows a robot. It is called as a industrial robot, or also called as kinematic chain. It is called as kinematic chain. We will see what is a kinematic chain. Kinematic chain is nothing but a few mechanical links are joined by appropriate joints, so they can be useful for doing some task in a given workspace. So, for example, we can see that this is an industrial robot. This is a table. There is a table on it which this has been bolted, or some platform is there. According to that, we have platform on which the bolts are fixed, so that the robot remain stable when it is moving. Otherwise, it will fall, tilt. Correct? That should not happen. So this is called as end effector. Short form is end effector or gripper in robotic terminology. And you see one part, a round part, it has some height, and this is called as link 0, L0. There's another link. This is called L1 link. This is third one is called L2 link. The fourth one is called L3 link. There are 4 links in this industrial robot. The black or browny, cement color. The whole thing is one link. This is one link, right? It is made of solid material. It can aluminum or stainless steel, something. You can see this is called link 0. Then the second one is called this part, the whole part. What I'm showing, this is the whole part is link 0, next link. These two, similarly, this part is the third part. This is called link 2. Generally, in robotics, links are numbered from 0 onwards. Link 0, link 1, link 2, link 3. It can go up to link number n if you need it. Not compulsorily, you can have n number of links, theoretically speaking, but in this case, we have 4 links. Then the fourth link is this, the whole thing. You can, it is made of solid materials, maybe aluminum, steel, depending on load carrying capacity. This is called link 3. Then this is called a wrist mechanism. This is called as wrist mechanism. And finally, this is called gripper. Gripper is like a finger-like structure. Here it is shown with the 2 fingers. Some robots may have 3 fingers, something can 4 fingers to act like a human hand and finger. Okay. So this is called, now if 2 links, correct, link 0 and link 1 are connected by one joint. There's a joint inside which is not visible, correct, which is called a rotary joint. In any machine, you will have 2 types of joint. One is called as prismatic joint or linear joint. This is the basic joint. The second type of joint is called rotary joint or revolute joint. These are 2, but the prismatic joint provides linear motion between 2 links. Correct? For example, I am drawing here, you can see that this is one joint link. first link. Okay, this is connected to one prismatic joint. Prismatic joint is generally represented as a piston moving inside the cylinder. Joint itself has two parts. One is a piston, other one is a cylinder. Both are together. They are called as a prismatic joint. The whole thing is called a prismatic joint or linear joint. So this joint, the outer body, which we call a piston, is one part of the linear joint that is connected to L0 link. First link is called L0, that is grounded. This is symbol for that means fixed, so that the L0 joint cannot move freely. It is bolted, correct, on somewhere at this is symbol for fixing or earthed, correct. In mechanical, it's a bolted fixed. One end of the elbow link 0 is this one. Other end is connected to the prismatic joint, nothing but body of the joint, which is called a cylinder. Inside that, the piston is moving. The piston can, you can see that piston can move inside, starting position with this dead end. I'm drawing with green, right? From here, it can move to the other dead end, which I'm drawing in another color here. Right? Violet is one end, when the piston is one end, dead end, right end. When it comes to left end, it is shown as green. But so that means it can move within this one. This is called a stroke length. So this is the distance. So how much distance now next thing what I want to show is the second link. Second link, I say L1 link, is attached to the piston. It is attached to the piston. Okay. L0 link is attached to the cylinder. Now, if I make the piston to move like this, left or right from center position, so with respect to L0, L1 can move. Correct? So, now I attach a finger, say end effector here. I attach the end effector at the right end of the L1 link. Left end of the L1 is connected to linear joint of prismatic joint moving piston. Similarly, L0 link, first link, the right end is connected to cylinder of the joint. The whole thing is called prismatic joint, linear joint. Piston cylinder together is called one joint, and this one. L0 other end is connected to ground. So that means, what is the job of the joint? The joint connects two links. Joint connects two links. Okay. Together, the link 0 L1 and this I call the joint one, J1. Joint, I say short form. First joint I say J1. Right? So the L0 L1 link is connected by the J1 joint. Together they are called as kinematic pair. Pair means two. Correct? Two links are joined by a joint. So the two links forms a kinematic pair. Okay. Now, in this rope, now what is the job of the joint? The joint, note down, this is very important. Joint provides a linear motion to L1 link with respect to L0 link. That means L1 can move with respect to, there is a relative motion between L0 cannot move because it's grounded one end. Other end is connected to joint. Joint other end is connected to L1 link. So that means only L1 link can move with respect to L0. Who is providing the relative motion? The joint. Without joint, there is no motion. Relative motion will not happen. So this is prismatic joint. Instead of that, I will draw another, this one, same. I have my L1 link, L0 link, and I connected a rotary joint. Rotary joint is shown like this. And this is my end effector. This is my L1 link. This is my R1. Correct? So again, it is J1 only, because in robotics, rotary joints are mentioned as small first letter R. The prismatic joint are taken as P. So if the first joint is prismatic, it mentioned as P1. And if this second joint is rotary joint, it will be R2. If third joint is rotary joint, it will be R3. If the fourth joint is a prismatic joint, it means mentioned as 4. I told you joints are numbered from 1, 2, 3, N, P, P, M. Correct? Similarly, the links are starting with L0, L1, L2, like that, LN. Last link can be LN, subscript N or this one. So, this is how general terminology used in the. Now, I told you that any machine will have links and joints. Again, yesterday also I told you that if you take IC engine, crankshaft is connected to connecting rod. Crankshaft is a link. The other link is connecting rod. They are connected by a rotary joint. Correct? So, with respect to crankshaft, the camshaft, the connecting rod can rotate, but of course, the connecting rod is connected to a piston. So, when crankshaft rotates, the connecting rod converts the mechanism, crank mechanism converts the connecting rod to move in linear motion to move the piston inside the cylinder. So now, before going further, I want to tell you, since we are talking industrial robot, if instead of this one, this is a prismatic joint, there is a basic joint which gives linear motion. L1 can move with respect to L0. Correct? So the distance moved is represented by D. This is the term we use. Correct? D can vary from 0 to 10 centimeter. That depends upon the movement of the joint. We call a stroke length. Stroke length, that means inside the piston, cylinder, the piston is moving from one end, which is marked green, to blue. The stroke length is 10 centimeter. I say displacement provided by the joint, prismatic joint to L1 with respect to L0 is 10 centimeter. It can vary from 0 to. Correct? So prismatic joint provide linear motion. There is a linear displacement. Instead of that, I can have a rotary joint. This is symbol for rotary joint. And L0 is connected to L1 through a rotary joint. And this can provide only rotary motion, 360-degree rotary motion. That means L1 can rotate 0 to 360 degrees with respect to L0 joint. L0 is grounded, right? The first joint is LD. The L0 one end is connected to ground, fixed on table, right? Just like this. So if we have the joint, first joint, the rotary joint, I represent R1. L1 can rotate clockwise, anti-clockwise, 360 degree with respect to L0. So the rotary joint provide rotational movement for the link. So again, we say that with respect to, that means relative motion. L1 rotate with respect to L0 any degrees. What is by doing it, what you are achieving? The end effector, correct? The end effector is attached to L1 and it can, suppose you attach a tool here, correct? The tool can move, correct? Once the joint rotates, the L1 also rotates, automatically the different position the L1 joint will take, correct? So it can take any, because I said it continues, it can move, correct, like this. So new position by moving the R1 is a rotary joint. So I say that the joint variable theta is vary from 0 to 360. What happens? The end effector, which is attached to L1, can move in a circular path. So the circular path is called as, note down, it is called as workspace. Correct? This is called, that means the tool attached to the end effector can reach any point in the circular path, any point. Infinite number of possibilities are there. Correct? So that is called a workspace of the robot. This robot, okay, let me clear everything. This robot, what I shown, is called single degree freedom robot. This is L0, this is L1, this is the joint R1, and the joint variable is theta. Correct? Theta can vary from 0 to 360. If I vary the joint variable, this one, the L1 link and the end which end effector attached and which I attached a tool. This tool can move in circular path. It cannot go any other path. It can reach only that path. Only these places I can drill anywhere. If the tool is a drilling tool, milling tool, that means in circular path, I cannot go and do any operation here. Correct? So this is called as workspace. Workspace for the single degree freedom rotary joint based robot. This since it has one joint, it provides what is in robotic called degrees of freedom. It is called 1 degree freedom. That's short form DOF, degree of freedom. This is terminology used to do. If I say, for example, similarly, I showed you previously one prismatic joint. I have L0 link connected by a prismatic joint, which is nothing but a piston moving inside the cylinder. The whole thing is joint. I say P1, this is my L1, and end effect is there. Right? So if I attach a tool, this can extend, correct? Piston can be, as I will show in different color, you will understand. Piston is here, end of this one. That means this is end effector position. When the piston is moved to the other dead end, right hand dead end, that means piston has come here, the end effector will be here. So that means the path followed by the tool or end effector will be a straight line. I can, by moving this prismatic joint, that means piston, I can make the end effector to move from this location to this length. Correct? What is path it is carrying? It is a linear path or a straight line. So that means there are two type of motions are possible, or end effector can reach in robot. One is straight line path called prismatic or linear path. Other one is called rotary point. If I use a rotary joint. Okay. Now, if another thing is in your industrial robot, or which is called as a serial kinematic chain. Why I call serial kinematic chain? There are 3 joints. There's a one joint here, another joint here, third joint is here. Correct? You can see here, and which is hidden. This is called R1 because the first joint, it is a rotary joint. I call it R1. The second joint also rotary joint. I call it R2. The third joint also is a rotary joint. That means with respect to this is L2, this is L1, this is L0, this is L3. Right? With respect to L0, by rotating, moving the R0 joint, L1 can rotate. What? Circular path. Right? With respect to circular path, it can rotate. If I move the R2 joint instead of R1 joint, right? If I move the R2 joint with respect to L1, L2 can rotate like this. Right? So then similarly, if I move the R3, the L3 can rotate with respect to L2. That means how many kinematic pairs are there? 3. We have 4 links, L0, L1, L2, L3, and we have 3 joints, all are rotary joints, R1, R2, R3. We have 3 kinematic pair. Correct? So this is for L0 is 1 kinematic pair, and L2 forms the second kinematic pair, L3, L4 form third kinematic pair. So how it is distributed? 3 rotary joints are there. Then what are degrees of freedom? If I have a rotary joint or a prismatic joint, one joint, I get 1 degree of freedom. How many joints this has? 3 joints. It has 3 prismatic, rotary joints. So this robot is called 3 degree freedom robot. Most of the industrial robot are 3 degree freedom robot. Most, there can be 4 degrees also. There can be 2 degrees also. There can be single degree robot. That means 2 links with 1 joint. Joint can be rotary joint, all those things. Correct? So this industrial robot, which is from KUKA, you can see the name. Most of the industrial robot, if you see the robot, correct? This is called robotic arm. They saw it as robotic arm. What is arm? Human arm. What is that? The robot is mimicking a human head. This is called the anthropomorphic robot. Correct? You can see that your hand, your body is considered L0, and you have a rotary joint. Correct? We have ball socket. Shoulder joint is called ball socket joint, or 3 degree freedom robot, because it can move in X direction, Y direction. Single joint can do 3 degree of freedom. That is beauty of the ball socket. Correct? Or spherical joint. They call spherical joint or ball socket joint. Correct? Technical name is spherical. It can give the attached link with 3 degrees X direction. With respect to X axis, it can rotate. With respect to Y axis, it can rotate. With respect to Z axis, rotate. So one joint can give 3 degree. But basic robot, as I told you, it can be a single degree rotary joint, single degree prismatic. But that's why I'm showing other joints also. Okay, fine. Now this robot has 3 joints. All the robot up to this, correct? This is what called a robot. Let me clear this so we have a clear idea. Up to this part, is called robotic arm. It has link 0, link 1, link 2, and link 3. So three joints, right? There is one joint R1, R2, and R3. So this is a 3-degree robotic arm because it is mimicking human arm. Then in your hand, what you have? Shoulder joint, correct? Body is considered L0. Next, from the shoulder joint, you have a bone, correct? Then you have one joint. So this can be considered as a shoulder joint. What is this joint? Anybody can give idea? In a human hand, what do you call?
Ball
Hello?
and socket.
Elbow joint.
That is called
Elbow.
elbow joint.
Elbow.
Yeah, that's called elbow joint, correct. This is called elbow joint, correct. So elbow joint is connecting the two bones, correct. The bone which is connected to ball socket to other end, and this is called the third link, correct. So this is called as wrist, correct. Then wrist mechanism is attached to your palm, correct. Then you have fingers. This is fingers. This is wrist mechanism, and you have the other joint, correct? Elbow joint, shoulder joint, and you have. So
Hello, sir.
yeah, yes, please.
This wrist mechanism is also considered the rotating joint, right?
That is good. See, in all living things, you have only rotary joints. You don't have any prismatic joint. No animal, no insect. All living things by nature they give only rotary joints. Wherever joint is there, do rotary joint only.
Yes, sir. I was asking in case of this robot also because we were only labeling R1, R2, R3.
Yeah, all are rotary. See, with respect to this is R1, this is R2, this is R3. That means with respect to this can rotate, with respect to this can rotate, with respect to this can rotate. The wrist mechanism provides 3-degree freedom. The wrist mechanism robot provides 3-degree. It is a ball socket mechanism similar to that. Single joint giving 3-degree. So this robot totally how many degrees? This is 1 degree first joint. Second joint, this provides 1 degree rotary motion. The third joint gives 1 degree freedom. The wrist mechanism provides 3-degree freedom to the end effector. When we talk about the degrees of freedom, we are talking with respect to base. Correct? This is base. With respect to base, the finger or gripper is going to move in the 3-dimensional space. So gripper only get 3-degree freedom. But if I talk with respect to first this one L0, L1, it has only 1 degree freedom because there is only one joint. As per if you consider this one, L2, this one, it has one joint here, 2 joint. L2 has 2-degree freedom. When you see L3, it has 3 degree. With respect to base, first joint gives 1 degree, second joint gives 2 degree, third joint gives 3. L3 link has 3 degrees of freedom. Automatically, this also get 3 degree of freedom. Anything after the joint gets all the freedom what the link is getting. Now, link mechanism is the last worker which has wrist mechanism which gives 3-degree freedom. So the gripper has totally 6 degrees of freedom. That's why this robot is called 6-degree freedom robot. Most of the industrial robot, what you see in industry can be 5-degree freedom to 7-degree freedom generally, based on this operation what it has to do, which is called a workspace. What is a workspace required? Depending on, it may be 5-degree robot at 6 degree or 7 degree, but 90% of robots are 5 degree or 6 degree. It is 6-degree freedom. That's what I told. Okay, you understand what it is. There are joints which give single degree, 2 degree, 3 degree, up to 3 degree. There are joints are available. For example, this is one type called turning pair, which you can see that this is one part. The whole thing is a joint. This is one part. This is the second part, correct? The second part can rotate with respect to what is called turning pair. It has 1 degree freedom. Again, this is rotary motion, correct? This is rotary joint. With respect to this part, the second part, shaft-like thing can rotate 360 degree, correct? So this is a rotary joint. The second one is called prismatic sliding joint. You can see that same thing. This is part one. The whole thing is called a joint. Please note that joint consists of two parts. Then you attach a link to this and another one to this. One is fixed, other one is a rotary moving part. Correct? So attach, this is my L1, this is my L0. If I connect, so with respect to L, if the joint moves, automatically with respect to L0, L1 will move. So this is called, it can move up and down, it cannot rotate because the square hole, correct? So this part can move up and down, it cannot rotate. So this joint is a prismatic joint. How many degree? 1 degree freedom only, correct? This part can move up and down only, it cannot rotate. So that means 1 degree motion with respect to one axis, correct? This is y axis, correct? It can move like this. This is, if you take the with respect to this y axis, this can rotate, correct? Only rotary motion possible, it cannot move up and down. That's how the arrangement. The other one is called screw pair. Screw pair also, you can see that by rotating, it can give a rotary motion, correct? And it gives a 1 degree freedom. Then you have cylindrical pair. Cylindrical pair, you can see that this is fixed, correct? This part is fixed. The second part, which is a pin-like structure, a cylindrical solid cylinder, it can rotate, also can move up and down. If I attach a part link here, L1, I attach my link 0 to the bottom part, L0, the link 1 can rotate, also can move up and down because the joint got 2 degree freedom. This is called cylindrical pair. I regular spherical band or with a ball socket, it provides 3 degree roll with respect to this axis, with respect to this axis, with respect to this axis, correct? I can call this Z axis, this I call it X axis, this is Y axis as per Cartesian coordinate. With respect to this, it can rotate, okay? So that is what only possible. So it gives 3 degree freedom rotation with respect to this. So the last one is the flat pair, correct? This is one part, this is second part. With this part 2, I can say part 2 can move like this because it is not attached, just touching and sitting on this part. It can move in the Y direction, X direction, also can rotate. It can give 3 degrees of freedom. So you can connect all these things to any of that, depending on requirement in your robot, you can get a degrees of freedom. Okay. So this is how the robot works. Okay. So next, I think what I want to talk about is already told what are the basic components of robot. It has links and joints. Any robot is only two type of parts. One is called link, other one is joint. What is the user? By link, joints are used to connect two links, and provides, note down this is important when provides a relative motion between the links. A relative motion between links. Okay. Then if two links are connected by a joint, it is called as a kinematic pair. Pair means two. Why it become kinematic pair? You are connecting two links, correct, by one joint. So the two links forms a kinematic pair. Kinematic means motion. As I told, with respect to one link, the other link can move in a linear way or rotary motion. That's why it is called a kinematic pair. Okay.
Sir,
Then,
excuse me, sir.
yeah.
I wasn't able to catch the word after if two links are connected are that word I wasn't able to catch. Some disturbance.
If two links are connected by a joint, sorry, by a joint, it is called as kinematic pair. And if two or more kinematic pairs are connected, pairs are connected by by joints, it is called as kinematic chain. And industrial robot is a kinematic chain. All industrial robot, most of the industrial robots are called kinematic chain or serial robots. Why? As I told you in the previous diagram, this is one kinematic pair. I say K1. This is the second kinematic K2. This together is called K3, and it is connected to wrist mechanism and end effector. Again, you can see that this is also one kinematic pair. There are three kinematic pairs. Correct? Having a common, because ball socket provides actually there are two parts only. It looks like two parts, but the actual this one is like a three mechanisms, one after another. All are rotary joints, and finally end effector connected to it as if three joints connect, three joints having common point of operation or center of location. So the wrist mechanism provide three links. That means basically look like. So you can see that this is a kinematic chain. This robot is a kinematic chain, correct? And since the links are connected serially, serial means first link L0 is connected to L1, L1 is connected to L2, L2 is connected to L3, and connected to wrist mechanism, which are L4, L5, L6, and finally end effector, correct? So they are all connected in serial, one after another. Connecting one after another is called serial. That's why it's called serial kinematic chain. There are parallel robots also. I am not going to discuss. We are not talking. That is separate course. Parallel robots are there, correct? There, the end effect will be connected to multiple kinematic chain, something like this. This is one part. This is the top part. This is, I say that this is correct. This is a parallel robot. Example, parallel robot. You can see that this is one part, top part. It is a plate, right? The plate is connected by to a this is kinematic. You can say link 0, link 1, link 2, link 3, link 4, link 5, and this is R1, R2, R3. Right? So if you are connected like this, you can see that the top part is nothing but L7. L7 is connected to three kinematic chain or kinematic pairs. Right? So this is called a parallel robot.
Octopus, sir. Octopus type.
Similar to that, but octopus, the tentacles have the unlimited flexibility. No, it can bend anyway. Right? Yeah, similar to that. You can think like that, but basically here in robot, everything is made of rigid link. Joint only provide linear. Octopus tentacles are made of soft material. So degrees of freedom is unlimited for octopus. But here, what is degrees of freedom now? 1, 2, 3, correct? And connected together, the L7 can move, correct? With respect to ground, different direction. It can move, tilt. It can tilt like it can tilt like this. By moving these joints, you can tilt the top plate any direction. Okay, so this is called parallel robot. Okay, so we are talking about serial robot. Now I talked about this one. So this is what the basic deal. So it is made of rigid parts, links and joints. Joints are used to connect the links and for the kinematic pair. And kinematic pairs are connected by kinematic chain, nothing but a serial. serial robot. So this is all this thing what you are forming a mechanical structure. By using joints and links, you are forming a mechanical structure. Okay, so this mechanical structure, correct? If you have a joint here, you have a joint here, there's a joint here, there are three joints in three XYZ direction. All these things are rigid, made of, for example, steel or aluminum, some rigid element. Then only rigidity will be there. But can they move on their own? The mechanical structure cannot move its own. It doesn't have energy source which provides a motion. Now the joints are there. Please note that already you have a joint. Joint is a mechanical structure, but it cannot move automatically. So what you have to do, along with joint, you attach a motor. Every joint below that you have a motor. Correct? Motor connects links and joint connects links, and there's a motor which gives the motion to the joint. Who is giving motion? The motor. For example, for you to understand quick, maybe, please know that motor is inside. Joint and motor is inside. Here also motor joint is inside. Here also motor and joint is there. Here also motor and joint. Nothing is visible. For you to understand, there's a figure I can show you next slide. Yeah, you can see here. Same robot. There's a motor here, which is not visible. There's a second motor, third motor. Correct? This is a different type of robot because this also 60-degree freedom robot only. Correct? So here we are saying M1 means motor 1, M2 is motor 2, M3 is motor 3, M4 is motor 4, M4, 6. These are motors. So the mechanical structure provides a shape and a workspace. Workspace means where this end effector can, correct? The end effector presently X, Y, Z in one location in three-dimensional space, correct? Then if I move this, this can become like this. Now it is, I say X1, Y1, Z1. Then I can move this like this also. I say X2, Y2, Z2. Correct? So by moving this joint, this mechanism, I can make the end effector to move different location. This is called a workspace. Now, if I move this joint, what will happen? This entire mechanism will move. If I move this joint, the whole thing will move. If I move this joint, entire robot moves. Correct? So the end effector can move in a what will be the workspace of this? It will be a semicircular dome. Correct? Is a semicircular, semi-spherical. You can say the not circle, semi-spherical dome. The end effector can reach anywhere in this point. Correct? That is called as the work volume. Work volume or workspace. If it is a 2-degree freedom robot, or if it is a planar robot, correct? If it is a planar robot, the workspace will be as an area. Correct? I say workspace, WS will be an area. Correct? So it can be a square type or it can be a circular space, something like this. If it is a 3-dimensional robot, correct? Then it may have a cuboid or a semicircular dome or different shape. That you can see it. That's not our interest, just I want to so this is an example. Okay, so a robot has a mechanical structure which is built using links and joint kinematics already we saw. Next thing is what it has is it has control circuit. It has a robot controller which consists of a microcontroller, a small computer, which is called as ECU or embedded controller. Electronic control unit or embedded controller. All machines which is needs to be controlled using automation, correct, will have an ECU or other, which is nothing but a small computer. It will have a CPU, it will have a memory, and it may have other amplifier circuit, correct, and power amplifier to drive the motor, all these things. All the circuit will be built in a single this one device, correct? So that is called a electronic control unit. And in this diagram, they are showing the motor controller with a microcontroller and the serial communication and the communication, the Bluetooth device, all these things, along with power electronic devices which drives the motors. There are 6 motors. This is a 6-degree freedom robot. To control each motor, you need a power electronic circuit. What is a power electronic circuit? Which is going to amplify signal coming from the computer. Signal coming from the computer will be 0 to 5 volts or 0 to 10 volts only. But the motor are maybe working at 100 volts or 200 volts or 400 volts depending upon power requirement, and may take current in the of 10 amps or 20 amps or 50 amps, anything, correct? So depending on load carrying, what is load it is going to carry. Depending on that, motor power will be selected and the motor will be operating some high voltage. So the controller generates in the order of 0 to 5 volt, 10 volt. This is voltage generate that cannot be used for driving the motor. So it needs to be amplified further. That is done by these power amplifiers. I say PA1, power amplifier 2, because there are 6 motor, each motor needs separate amplifier. PA5 and PA6. So that means if you see an industrial robot, you have a mechanical structure which is made of joints and links, and also it has electronic circuit, driver circuit, and also a computer. Correct? So that's what is shown here. So that means here we are showing this one. This robot end effector position should be considered. Actually, they call it a pose. Pose of the end effector. EE should be controlled or varied to, because we are going to, it is going to carry an object, moving object from location X to Y. For example, in industry, from conveyor belt something coming, it has to pick and put place in somewhere else. Just 1 minute, be on the line, I will be coming. No. It's
find submission stop it due to some startup down. This Canadian code can give a copy. Just to declare sign sign and stamp. That's how I understand it.
No, I understand.
Because no, sir, because he was
I am taking class.
I am not disturbing.
No.
All are duty. All are books. Yeah, books. Springer is our publishers. So you want to write something for us?
No. So each book is 1,500. 10 books.
10 books.
5 books. This is 5 books.
All are good. After discount 35.
Okay, I need some time because I have to visit. There are probably around 20 books. So it comes on the 40 letters or 50.
No. It's all are Indian.
Yeah, that's what I'm saying. Each book is 2,000. No?
After 35% discount.
This is price for individual book or for all the 5 books is 2,199. Each book is.
Each book.
That's what I'm saying. 30, 40,000. I have to look into it. Meet me tomorrow.
Tomorrow, when, sir?
No, this is a recommendation letter, no?
Yes.
I will pass it to the new one.
Oh.
I will pass it to, because I have to go through, talk to faculty, and then I will pass it.
No. Thank you. Sir, if you want to write something for us, we have a speaker or two copies.
Maybe later.
Okay, sir. Thank you.
But this I will talk to HOD and find out whether funding is there or library. Then I will pass. Whichever is possible recommendation.
Thank you, sir.
Okay, thanks. Thank you. Thank you. Sorry, somebody was waiting outside for a very long time, so I need to just.
No issues, sir. Please, no issues.
Okay, fine. So this picture shows the what is the functional block diagram. Please take down these pictures, the diagrams. This diagram is not needed. This is for you to understand. But this diagram, right? You have to note down. Okay. So in the exam, if you are asked to write about robot and the functional block diagram, this diagram you should draw. I'm just giving an example, correct? I'm not going to ask the same question, but I'm saying that's why any three-dimensional photograph, all those things you need not take. But other than this kind of line drawing, line sketch called functional block diagram or bulleted points, all those things you should note down. Because that is needed for your exam. Okay, you can see that I wanted to control this robot. I want to control this robot, which is a 6 degree freedom robot. And in the robot, apart from the each joint, there are another one more thing. Each joint there's a motor, correct? The motors are meant for driving the links. The motors are driving the links. So that means each kinematic, each joint will have one actuator. If it is a rotary joint, it will have a motor. Right? If it is a linear rotary joint, if it is a prismatic joint, it may have a solenoid. Correct? So you have a prismatic joint. I told you it looks like a piston and a cylinder. Correct? So this is piston. This will be powered by a solenoid. What is the electrical actuator? For example, actuator can be electrical, hydraulic, pneumatic. Correct? So if it is this one, it is a solenoid which will supply current so that it will make the piston to move inside this one, giving a displacement. Right? So solenoid actuator will be used. If the rotary this one, it will be a motor, electric motor or hydraulic motor, servo motor. Correct? It can be there. So that means in this robot, you have mechanical structure made of joint and legs. Then you have motors because this robot is a uses 6 degree freedom robot having 6 rotary joint. So that means 6 motors are there, M1 to M6. Then when I want to move the end effector, by moving the joint, the position of the end effector with respect to XYZ axis in 3-dimensional space it can move by moving these 6 motors. That is what as kinematic equation or analysis. Right? So you can find out if we know that there are 6 joints, theta 1, the first joint, where joint variable is being a rotary theta 2, this is called theta 3, theta 4, theta 5, and theta 6. Correct? That means if I want to vary the joint angle, I have to actuate this motor by giving some supply voltage. Whenever the controller want to move particular motor, it will supply a control signal to this power amplifier, which in turn will send the voltage, right voltage, 0 to 100 volts to vary the motor speed. In a motor, the electric motor, the torque produced is directly proportional to current. The current is proportional to voltage supplied for given motor. Motor is a coil distance. So if I supply this motor, then speed or omega, then there is angular speed we talk in omega, position we call in theta. The angular speed is controlled by voltage applied. By varying voltage, you can change the velocity or angular velocity. By controlling current, you can control the torque produced. Torque, they say how much load the end effector can carry. Because the load end effector is going to carry only when the motor moves. Motor movement is decided by the current supply. Correct? So depending on the weight of this one, torque needed will increase or decrease depending on end effector. Say for example, I have a load of 10 kg. And if this motor has to rotate or move, then you have to supply sufficient current to carry this load. Okay? So that is what the power amplifier comes to this picture. Okay. Now the kinematic equation to gives the relationship between the joint angle and this one. Let me, before closing, I will tell one example. For example, I have a single degree freedom robot. Okay. That means I have only one joint, a rotary joint. connected to second link. This is my end effector gripper. Okay, and this is a 2D 1 degree freedom robot and planar. Okay, so that means this is L0, this is L1, this is R1. Okay, now the L0 is fixed. R1, if R1 changes, that means I have a motor attached to it. Okay, and this is supplied with a voltage by a controller. Controller is supplying a voltage V motor. This is controller, so this is supplying to motor. If it gives, so the motor will rotate clockwise or anti-clockwise by some degree. Okay, so that means this is, I call this theta 1. Okay, so now the end effector is a planar robot. That means it moves with respect to xy, no z-axis movement. So I say that x comma y, and it can say that now currently I call it x0 y0. If then I wanted to find out with respect to base, because my interest is with respect to base where the end effector is. The position of end effector can be controlled by varying the theta. Theta can be varied from 0 to 360 degree. Right? So then I can write an equation. X equal to, this is we call as L1, this is called as L0. Correct? Where the joint is connected end effect, that means this can rotate like this only. Correct? I already told you work space or work volume of single degree robot having a rotary joint is a circular path. Here only it can move, nowhere else. Correct? That is the workspace. So now, depending upon the theta, the position in the two-dimensional workspace, correct? I can put graph, imaginary axis. I call this y, this is called x, this is a plus, this is x minus, this is origin 0, origin, y plus, and this is y minus. Correct? With respect to origin. So I put my imaginary frame attached. We call the xy coordinates the coordinate or frame at the joint position. So if I vary theta, then with where the position I can always calculate without doing experiment. This is called a mathematical model or kinematic model of this robot. Kinematic model of robot is nothing but L1 into cos theta 1 and y, the positional end effector y equal to L1 into sin theta 1. These two equations are kinematic model of robot. I have modeled my robot. What I can do with the kinematic model, if we know that x and y are the positional end effector with respect to the origin. This is origin, correct? This is my origin. With respect to this, where my end effector is. That I can calculate using this equation. These two equations are kinematic equation, in which L1 represent link length. Second link, but L0 immaterial because it's not going to move. You are moving joint one only. So that means link length of the first link, and theta is called a joint. This is called link variable. This is called as link variable. L1 is length of link, but once a robot is made, it is fixed. Before, while designing robot, you can take this one depending upon what should be radius of this workspace. Correct? That decided by L1. As per this is circular path only. The workspace of this robot is a circular path, correct? That the circle means a radius. Radius of the path, this is link length. So if I want this to be 0.5 meter, my link length will be 0.5 meter. If I want 1 meter, that means my circle will be like this. Please note that end effector can reach only these points only, not anywhere other than that. That is a single degree freedom robot limitation. Okay. Now already made my robot with 0.5 meter length. Then I am varying, this is called joint variable. Theta is called joint variable. If I vary joint variable 0 to 360, correct, and I substituted that value, here it will always be 0.5. The theta alone will vary so that I can find out what will be the positional end effector in two-dimensional space, x and y, correct? That is location of the end effector. X and y location or current location. That depends upon theta value. Correct? By way, how I vary theta? By making the the motor to rotate. How will you make the motor to rotate? By supplying a right voltage. Then I write a control program in my embedded controller. It will control the motor, so the position of the end effector can move in the workspace. This is how the robot works. Okay, so take this picture and you can understand the functional block diagram. Correct. Motion planner. I say that what should be path in a 2D workspace. Correct. I want to move my end effector like this, something like this. This is starting position. This is the end position. Right. So this is my imaginary axis, reference x comma y. Right. This is y and this is x. Here only my joint is there. Correct. Single degree freedom or 2 this one. So my robot is attached. Correct. And the end effector. So the end effector should move something like this path. It has to path. That path is given motion. So if it is given, as the end effector has to move follow this path, we need to calculate for example, this is a 2 degree freedom robot. I have theta 1 and theta 2. Correct. In that case, theta 1 and theta 2 to achieve this position path. What should be? You need to calculate. That is called as inverse kinematic model. Note down. Inverse kinematic model. In robotics, it is called as inverse kinematic. Already, we know the forward kinematic. Already know if L1 and theta is known, theta, then I can calculate what is x and y, where the end effector. Now what I am doing inverse. I want the end effector to be moving in this particular path. That means I know x comma y, correct, for a different position. Correct. 10 comma 10, 10 comma 15, 20 comma 13, something like that. Correct. This is the path it is following. If I give this value, the robot, correct, the robot controller should calculate the theta 1 is called joint angles.
Sir, sorry to disturb you, sir. Another 4-5 minutes is available, sir.
Yeah, now I am going to stop.
Okay.
Okay, I am going to stop. You have to go. Correct. So you have that is called inward kinematic model. So you may use forward inward kinematic, which is run in the computer. So this function, this is mechanical structure robot. Correct. I am talking about one kinematic path. One motor is there. Correct. It consists of L0, L1, and this is my motor, which needs to be controlled by a power amplifier, which in turn is controlled by the computer. Motion control, nothing but my ECU. Correct. ECU, if you give the position, end effector position, where the x comma y or x comma z 3-dimensional this one, the software will compute theta 1, theta 2, and theta 3, and the motion. This is what is going to come. The software which is going to reside in the motion ECU. Correct. Calculate and generate the control signal due to power amplifier, which in turn is motor. So motor moves the joint. So the end effector, by moving the joint, it reaches. Correct. And I want to know where the end effector current position. If you know, that means I should know the theta 1, theta 2 happen. Correct. That should be founded. That to find out that you will get a sensor, feedback sensor. So note down this. I will show this. Anyhow, next class I will show one briefly. Then we go to next example. So have a nice weekend. We'll see you on next Monday. 2 more examples. Then we'll see. Okay.
Thank you, Mr.
Yeah.
Thank you, sir.
Give your attendance before going. Thank you.
Yeah, thank you, sir.
Yeah.
Hello, sir.
Yeah. Yes, please.
Sir, do we have any portal for accessing the SAE website, student login?
Portal for?
SAE.
You can log in through library portal. SAE journals you can see, but you will not be able to access outside the IIT. First, you need to get your library card, and already somebody sent a mail. I am talking with the people to get your library at the earliest. Only after getting library card, this one you can do. But online you can access using library card, your SMail account you can access, but that is possible only when you are inside the campus.
Okay.
Outside the campus, IIT, you are not allowed. Our server won't allow. You have to log in from the IIT inside, and that also SMail account.
Okay. So when
that means you have to come here only, no other option.
Okay, got it.
Okay, sir. Just one more point, sir. The 24 batch can we get the ID card?
Yeah, I saw the mail. I think. What is your name?
Oh, Chidambaram, sir.
Yeah, I saw the mail. I am already talking with them. They will make up. Maybe within a week you will get the cards.
Okay, sir. Do we need to provide any photos initially we submitted? Will that be fine, sir?
That's what I need to find out. I saw your mail. Tomorrow, I will, because today I had some classes, exams, all those things. Tomorrow, I will contact our library and the code office and make arrangement. If they want photo, you need to supply photo. Soft copy through mail also can supply. There is sufficient. And the code office, so they will contact you. Sivagami or Dhanal will contact regarding any photo requirement by tomorrow. Okay.
Sure, sir. Sure. Thank you, sir. Thank you.
Okay. Take care.
Sure. Yeah, thank you.
Have a nice weekend. We'll see you on Monday.
Thank you, Professor.
Yeah.
Thank you.
Thank you, sir.
Yeah.